the car was moving to the left. That's the interpretation of the negative sign. In terms of moment, we are considering a system which is balanced. For moment is equal to force multiplied by perpendicular distance. That is force multiplied by perpendicular distance. We don't really, any equation that we are going to relate is supposed to be like this. Now, if we are considering this system over here, we can talk about the clockwise direction and we can talk about anti-clockwise direction. Remember, for an object to turn, it doesn't only depend on the moment, it also depends on the force on the object. There can be upward forces and then downward forces. But for the system to be in equilibrium, we consider all the things that can cause the object to turn, which is 1, the forces on the object, and 2, the moment on the object. So for a balanced system, or for a system to be in equilibrium, what we know is that first condition, net moment supposed to be 0. And then net force is also supposed to be 0. This is the condition for a system to be balanced. The net moment, you can say sum of clockwise moment is equal to sum of anticlockwise moment. The net force is 0. You can also say sum of upward forces is equal to sum of downward forces, or the resultant force on the object is 0. So in this case, we are not causing any turning effect of the system. We want the system to remain as it is. So since we are considering a system like this, there will be a force here, another force here, there will be a distance here, another distance here. If you want to use the principle of moment, what the principle of moment says is that the sum of clockwise moment is equal to the sum of anticlockwise moment. So principle of for the sum of clockwise moment, we are talking about the system from the turning point or the reference point. The clockwise moment, you have the clockwise force and the clockwise distance. So we get clockwise moment represented by Cm equals anticlockwise moment represented by AC.